to the demo showcasing real-time application performance on VMware Edge Compute Stack. We start by understanding the real-time application requirements at the edge. Traditional OT environments deploy physical devices for meeting their real-time edge requirements. For example, physical PLCs deployed in manufacturing plants for production line automation in a factory floor, and physical IEDs deployed in electric grids for protection and control at the electrical substation. Virtualization brings in a multitude of benefits as witnessed in the IT industry, but require COTS hardware to support real-time capabilities to support these use cases at the edge. VMware Edge Compute Stack comes in as a solution that provides a platform to run real-time applications, ensuring the required protocols are supported while providing the expected latencies. In this demo environment, we have an edge server with 32 logical CPUs. We have deployed VMware Edge Compute Stack 3.7 on this server. Then we deploy 3 VMs on top of it by defining them as YAML files in a Git repository. The first is a load VM with 16 CPUs used to stress the hardware. The second is a real-time workload VM. And the third is a non-real-time workload VM. The workload VMs are used to test the performance on real-time versus non-real-time applications on ECS. To enable real-time workload, there are a few settings we enable for the virtual machine. We enable CPU and memory reservation, disable logging, and set the latency sensitivity to high. For non-real-time workload, we leave it to the default settings. For the load VM, we provide it with 16 CPUs and run a stress test to increase the load on all CPUs to 100%. All of these settings can be enabled on VMware Edge Compute Stack using the Git repository that stores the application configuration. Here are the kernel settings that are set on both the real-time and non-real-time workload, such as avoiding periodic timer interrupts and preventing the CPU from going into deep sleep state. These are defined within the application OVA file itself. After initiating the stress test, we will run the cyclic test on the real-time and non-real-time workloads and compare the performance on each of them. We start by navigating to the VMware Edge Cloud Orchestrator UI. You can download the VMware Edge Compute Stack image from here. We have already downloaded and installed it on our Edge server for this demo. We have also added the server as a host in VMware Edge Cloud Orchestrator. If you would like to know more about the host addition process, check out our other videos on the VMware SASE and Edge channel. We navigate to our Git repository that stores our application configuration and take a look at the files available. rtvm.yaml defines the real-time application with real-time settings such as latency sensitivity set to high. It is important to understand that VMware Edge Compute Stack abstracts multiple manual configurations via the desired state methodology through Git. For example, the desired state allows us to define the number of CPUs we want to reserve for the VM instead of having to worry about the frequency of the CPUs that we need to reserve, because there can be multiple CPUs with different frequencies which need to be accounted for. Non-rt.yaml defines the non-real-time application configuration, and we have a load VM file as well. Now we navigate back to VMware Edge Cloud Orchestrator to see that our Git repository, site, and host has been added. Now that our applications are deployed, we navigate to the ECS host to verify if the real-time settings defined in the Git repository have been applied or not. We check the settings of the real-time application and see that the CPU reservation is set. The memory reservation has been set as well. Logging has been disabled and latency sensitivity is set to high. Now we take a look at the settings of the non-real-time workload. We see that no CPU reservation has been set, no memory reservation has been set as well. Logging has been enabled and latency sensitivity is set to normal. Now we take a look at the load VM and see that it has been assigned 16 CPUs. Now that we have seen the environment setup, let's check the application performance. We log into the CLI of each of the VMs and see that one CPU has been isolated and the profile is set to real-time on both the applications. Thus, they have identical settings at the OS level. Now we are going to run the cyclic test to measure the CPU performance and notice the processing latency. We initiate the cyclic test and notice that the latency is less than 10 microseconds on both applications. Now we navigate to the load VM. We see that the CPU usage is around 0. We then initiate the stress test on all 16 CPUs on the load VM. and notice that the CPU utilization has reached 100% on all CPUs. Now we navigate back to our workloads and see that the real-time workload latency remains almost constant, whereas the latency for non-real-time workload has increased many folds. We navigate to the monitoring tab and notice that the CPU utilization on the server has crossed 100%. Hence, we see that even after the settings at the OS level remain the same, the settings change for real-time workloads at the Git repository level allows CPU and memory reservation for the application, thus allowing VMware Edge Compute Stack to support real-time applications.